On this lab work, today, the one due this week or last week? 12? 12? Lab work 13, the one due this weekend. Okay. What did I say last week? Oh, number one, never mind. Number one is something that you're actually learning today. That is literally dividing fractions. Okay. Number two is what I talked about last week. So, any other questions? So the question was about number one on lab work 13, which is exactly what we're going to be talking about today. Any other questions? The last three, yes. The last three are equations. Yeah. We'll be talking about the last three, which are equations. Absolutely. You're good. All right, so number one. So in terms of lab work 12, the answer key is done. It was on number 3. And what I'm going to do is it's coming to my attention that, well, it seems like, I should say, I can't assume this. It seems like that many of you guys don't want to use ChatGPT, which is a little bothersome. I know that you want to do things your way, but when I give you an option that can assist you, you don't want to use it. And maybe it's because I'm mentioning it and not you. It is not your idea. I'm trying to make it so that I'm trying to teach you how to help it assist you. Right? Just the same way as the way ChatGPT or AI assists my mom. Right? So, for example, last couple of weeks, actually, last few years, I've been suffering something called a cold stomach. You've never heard of it before because it's actually an Asian thing. It's an Eastern medicine thing, not a Western medicine thing. If you go to the doctors and ask what's a cold stomach, they'll be like, I don't know what that is. But in the Chinese tradition, there is such a thing. In fact, in the Chinese tradition, up north, because the houses are made of wood, even though if there is, it's joists and there is a drywall, there's insulation between the walls, there's an outer wall, there is lining on the outside wall, there is siding on the outside wall. What the Chinese believe is that you should never put your head of your bed towards the outside wall. It should always be against an inside wall. And especially if you don't have a headboard, like a solid headboard in terms of another barrier to block air. What the Chinese believe is that the air actually does blow through the wall. You don't feel the draft. But the air can come from the outside wall to the inside wall. And when that air seeps into your head, into your pores, you can actually get migraines and headaches. For example, I was at Lake Park Diner, and there was a fan overhead that was blowing above my head. But obviously, because it spans out, I feel it on my head. And within the next 5 minutes, I got a headache. So I had to ask for the fan to be turned off. I never believed it until it happened to me. My mom always brought it up to me, never believed it. In fact, up north, when I used to go home to visit, I would be sleeping in my bed, and that bed, the head is against the outside wall. And it's like the bottom of a bunk bed. So bunk bed is just a rail that's considered the headboard, but it's clear, right? There's nothing blocking it. So one night, I got the headache. The next night, I took a blanket and put it over the piece, and the next night, didn't get a headache. Right? So the cold stomach has something to do with your stomach, and essentially what happens when it's imbalanced, you have certain issues. And part of it is drinking cold stuff, but it's not just that simple. Just because you start drinking warm stuff doesn't mean it goes away. There has to be other intervention that has to go into it. And that's what I've been doing after that last few years. Essentially, this is going to be a TMI moment here, is that, and it's going to be recorded, yikes, is that what happens is that in the middle of the night, essentially, my system just starts producing gas. It just starts to bubble. Every single morning, I'll have diarrhea. Not based on what I ate, but because of the cold stomach. My mom knew some remedies for it because she's known people with a cold stomach and a hot stomach. She had said that traditionally women have always had a colder stomach than men do, but it can happen to everybody. So as she was doing research in AI, so back in the day we would Google something, right? You had to pick the article that you think is legit and stuff like that. So she used AI, and ginger was one of those things. And what she also found out was having too much ginger could be bad for you as well. Can give you headaches, can give you other issues, right? So it's like, hey, when this passes, you gotta kind of be you gotta be moderate about your ginger intake. So if it wasn't for AI, she might not know that fact, because she can have ginger every day because she's always had a cold stomach, right? So she's kind of like keeping it at bay. So those are some of the things that AI can help with as an assistant. And there's the reason why I try to have you guys using it to assist you, not as a cheating mechanism, but because sometimes we forget what we've written down in the notes. And it's hard because you guys don't like to condense your notes. You guys don't like to necessarily write down what I've said to you as the step-by-step for the what we know, so you guys go into your own way, right? So what I'm going to do with this lab work is that I'm going to send you the answer key. I'm going to send you the rubric, and I want to have you guys tell me what grade you think you deserve. Okay? So for example, I'll bring this up to you guys. So if you look on the right side, this is everything that I wrote down. Break down each radical with prime factorization, factor tree. Would I be correct that that's something that we did? Identify the index of the root, R, number in the wedge. When there's no number, it's understood to be that R is equal to 2. We're looking for R of a kind. And when I wrote that, I was like, I'm not sure if everybody understands what that means, R of a kind. So I said, if there are R of a kind in the radicand, move them outside the house. Else, leave them in the radicand. For example, if the index r is equal to 3, then the cube root of x to the fourth will be the x comes out. The x that's now highlighted stays inside. If r is equal to 2, so I can show that there is no number in the wedge, is known to be a 2, right? And then I said to multiply or divide radicals, index or root has to be the same, right? Then it's outside times outside, inside times inside. Question is, if I gave you this, would you be able to do the problem on the left? Okay. So in the what we know, so since you guys are in class, I'm going to explain the rubric, but I'm going to send the rubric to everybody. If you have all of those things on the what we know, you get a 4 out of 4. If you're missing something, 3 out of 4. If you're missing a lot of the things, 1 out of 4. If you didn't do it, 0 out of 4. On the left, the work and understanding. If you show all that work, 4 out of 4. If they didn't show the if you didn't show the prime factorization, right, and stuff like that, or one or two things, 3 out of 4. If you're missing more than that, 1 out of 4. If you didn't show any work, you just went from the question to the answer, 0 out of 4, right? If you didn't identify the index, that's one thing as well, okay? And then you look at your scan. Do you think it was a good scan? Is there spirals? Is there shadows? Is there any of those things? Most of the time, I give you guys a 2 out of 2 on that, unless it's like blurry, right? Or spirals are in it, your thumb is in it, then it goes to a 1 out of 2. Okay? So I'm going to have you guys reply to me and saying, I think I have a 7 out of 10, 6 out of 10, 10 out of 10, 9 out of 10, whatever, right? Or if you want to give me a percentage, that's fine, because a 7 out of 10 is just a 70%. Okay? So I'm going to leave that up to you guys. Any questions on this? So again, when I said the what we know, one of the things I said last week was this, right? It's almost worthwhile doing all the problems and saying which ones are similar. So if I go back to lab work 12, let me do that really quick. If I go back to lab work 12, 2, 3, 5, 8, 9, well, yeah, 2, 3, 5, 8, right? You could even include in there 6, 9, and 10, right? If you did those all together and saying, okay, what are some of the changes within those? Well, the index changed. So I should explain about the index, right? In fact, I think that this, what we know, could essentially take care of majority of those. Really, actually, all of them. So it would be one what we know for 1, 2, 3, 4, 5, 6, 7, 8 of them. So for 8 of them, you would have had the same what we know. That's why I was saying that I know that you guys want to do the lab work and you draw the line and you just start doing it and you're like, okay, this is the what we know for this problem. It's not the case. Because now if you have 8 different what we knows for those 8 problems, then guess what? You're trying to remember 8 different things. It should be 1, what we know for those 8 things. Does that make sense or no? Do we have questions about that? People at home, any questions about that? Okay. So again, I'm going to let you guys decide what grade you deserve. And we'll go from there. Okay? All right. So let's talk about today. So one of the things I said to you guys is that I wanted you guys to have a full brain when we're doing dividing radical. And the reason why, so this dividing radical, so we already talked about multiplying dividing radicals before, right? Same index, outside times outside, inside times inside, or outside divided by outside, inside divided by inside. So why do we do a separate lesson on multiplying, a separate lesson on dividing? Well, the separate lesson on multiplying was bringing stuff that we did with polynomials, like distributing, double distributing, and stuff like that. Dividing, same thing. It's something more to it. It's not just outside times outside, inside times inside. Okay? In this case, what we're really talking about is rationalizing the denominator. So that's what we're really talking about, is rationalize the denominator. And you're probably wondering, what the heck does it mean to rationalize the denominator? And why are we doing that? And the reason why we're doing that, and this is why I was saying that the dividing in lab work 12 is much easier than the quote-unquote dividing in lab work 13. The reason why we rationalize the denominator is because we can't have radicals in the denominators. Oops. We cannot have radicals in the denominator. So once we have radicals in the denominator, we have to get rid of them. So my question to you is, would you like to do the easy method first or the hard? Okay, let me refine that. Sorry. So what we do with a monomial in the denominator and what we do with a binomial in the denominator are 2 different methods. Just like when we did with polynomials. When we divided by a monomial, we did one thing, right? When we divided by a binomial, we did something different. Long division. Remember that? So is the same thing here. The method for monomial and the method for binomial are going to be 2 different methods. You can't interchange them. You can't use the method of monomials for binomial. You can't use the method of binomial with monomial. One is easier. One is harder. Just like dividing by in polynomials. Dividing by monomial was easier because you just made different fractions. Divided by binomial was a lot harder because we had to do long division. So the question here is, do you want to know the easier first and then the harder, or the harder first then the easier? Your choice. At home, you guys want to do H for harder, E for easier. You tell me. I actually didn't hear you.
Well, you can do the hard first.
Hard first. Okay. Someone else voted hard as well. So here we go. So let's talk about the easy sorry, the hard, okay. So we're going to talk about monomial. So we're dividing by a monomial, or if the denominator is a monomial. So this is about the denominator. And again, it has to be a radical in the denominator. Okay? So let's start with an example. Now, one of the things we said was that we can split this apart. Right? We can split that apart. Guessing no questions there. So would you agree with me that this equals this? Notice in the denominator, I have a radical. I can't break that down. Agreed? Okay. So this is where we have the issue. We see a radical in the denominator. This cannot be an answer. So this is when we would rationalize the denominator. Okay? So here's my question. What do I need to multiply square root of x by so that the radical disappears? Huh? You think just times x? So if I multiply this by x, what would the result be? Wouldn't it just be x square root x? So that doesn't work. So I want to remind you guys, what is the index here? So how many of a kind are we looking for? 2 of a kind. So again, square root of x times what would get rid of that square root? Ooh. What if we multiply it by the square root of x? And if I do it to the bottom, I have to do it to the top. Agreed? So what is square root of x times square root of x? Wouldn't that just be x? Now that the square root is gone, I can have that as my answer. Does that make sense? And of course you're going, that seems pretty easy and this is supposed to be hard? Yes and no. This is the easiest of the hard. I'm kind of throwing you guys in the trap here. So right here, your first thought is, hey, I'm just going to multiply that by the square root of 28x. Is that what you think? Because that's what we just did on top, right? You're like, I'm just going to multiply by the square root of 28x. You could do that. And the reason why I was saying that was the easiest of the hard is because of this. What would you have to do with that one then? Because the index is a 3, right? If there's an index of a 3, then how many do I need? So so please don't write anything. I just want you to pay attention right now. So here, you could do that because the index is a 2. Here, I have 2 of them. Agreed? Okay. The problem is this. When we get to this problem, however, because the index is a 3, I would have to do that because I need 3 of them. Now imagine if it's a 4. So the question is, do you want to do this work? If this makes sense to you, you are welcome to do this if you want to. And I just want you guys to understand something. I want you to understand this. So what I'm about to show you is what my physics professor actually showed me when I was in your seats. I was trying to figure out where the heck I went wrong. And my physics professor looked at the paper and going, what in the world are you doing? Why are you doing this? I'm like, isn't that what you're supposed to do? He goes, yeah, but why are you doing all that extra work for? I go, please show me. His name was Dr. Dos Santos. Great man. He was like a dark-haired Justin Timberlake. So, this is what I'm going to tell you to do. I'm going to tell you that what you should do is, first, like everything else that we've done so far, is to break down the radical. What does 28x break down to? 7. Excellent. So 2 times 2 times 7 times x. Does everybody agree? Okay. So we have that broken down. So again, we're breaking everything down first. Right? We have to identify the index. Actually, which means that I'm looking for, I don't even know where to put this. I'll just leave it there for now. I'm looking for 2 of a kind, right? Okay. So here is where the work comes into play. I promise you it's going to make things simpler. We're going to make what I call a haves and needs table. So I got to write down what I have. I'm going to write down what we need based on the index or root being a 2. Okay? We're only looking at the denominator because it's the denominator that can have a radical, which is where we have the radical. So the question is, what do we have? Look in the radicand. If you look at the radicand, what do we have? We have 2 times 2. Is that right? We have a 7, and we have an x. All true? Okay. Now, the index is a 2, is that right? So we're looking for 2 of a kind. Do we have 2 2s already? Yes. So I don't need any more 2s. I have a 7. What do I need to get 2 7s? I need another 7. I need a 7. How many x's do I need? 1 more x. So we look here right now with our haves and needs. Do you agree that there's 2 2s, 2 7s, 2 x's? Awesome. So what I do with the need is I'm going to multiply by the square root of 7x. Everybody see where that came from? Yeah, if I do it to the bottom, I got to do it to the top. So again, this is my have. This is what I need. Got it? And if I do it to the bottom, I got to do it to the top, right? Awesome. Now, top is pretty easy. It's 3 square root of 7x. Right? The bottom. Do you agree with me that if I multiply this, it's inside times inside? Inside that radicand, I have a pair of 2's, I have a pair of 7's, I have a pair of x. Agreed? That means a 2 comes out, a 7 comes out, and an x comes out. Is there anything left inside the house? No. And there's my answer. Questions? Anything I can clarify here? We would do pretty much the same thing for the next problem. Are we okay here? Any questions, anything that I need to clarify in what I did here? Nothing? Okay. If that's the case, why don't you guys try it with that problem right there? Go bananas. Go bananas. you doing? I already broke it down for you. Yeah. I already broke everything down for you. You're just looking for three of a kind now. I already broke it down for you. We just got to make the table. Mm-hmm. Because nothing comes out, right? Okay. Just like the last step I brought up. You can't multiply outside with inside. Right? The inside has to be inside, the outside is outside. Right? How are we doing at home? We're doing okay? Are we stuck anywhere? Is that what we needed? If I do it to the bottom, I got to do it to the top. And if you notice that in here, oops, sorry, I missed some things here. There we go. So we notice up here, guys, in this radical, nothing comes out. Is that right? So that means I got to multiply them all together. So I'm going to have 3, the cube root of 2 times 7 times 7. What's 2 times 7 times 7? The bottom, same thing. If we multiply these two, inside times inside, outside times outside, if we do that, we're going to have 3 of a kind, 3 of a kind, and 3 of a kind. So that means I'm going to have a 2, a 7, and an x. there's my answer. Any questions there? Does that make sense? No questions. We're good. Nothing. All right, so let's talk about dividing binomial. So as we said, this is supposed to be the easier of the two. But it seems like you guys understood the monomial pretty easily, even though it's the hard stuff, right? Trust me, the table will make it easier. You decided not to make the table, you're just going to make things harder. Okay? The table does help. This is easier. What do I mean? Let's start with an example. Okay. That's not a circle, bud. There you go. So if you look at that denominator, there is a radical. 11 does not break down. And if you look at the denominator, that's a binomial. Right? Remember, binomial, trinomials are separated by addition, subtraction signs, right? So that is two terms right there. That's a binomial. So first, obviously, we got to be able to identify if it's a monomial or binomial. This is a binomial. What we had up there, there's no addition, subtraction sign, so therefore, those are monomials, right? So what do I need to multiply this denominator by so that that radical will go away? I know what you want to say. Feel free to say it if you want to say it. Anybody want to say, take a chance?
Like the same bottom.
So you think like this?
Yeah.
Okay. So let's take a look. So again, don't write anything. If I was to do that, this is what I'm going to get. Dang it, I still have the same, I still have a radical. But what she said was close. Very close. What have we done in the past? Because if you look over here, right, I call it double distribute. Some of you guys call it FOIL. I mean, we're really still foiling here, right? Because this is still my first, my outer, my inner, and my last. What part of FOIL has the radical in it? Look at it. Which part of the FOIL has radical in it? Isn't the oi? Right? My first and last doesn't have radicals. It's my oi. What have we done in the past where the oi goes away? I brought this up last time too. Anytime we play hangman, that's going to be the word. So if you don't remember the word, start guessing letters. Should I use this, say that? Anybody have a letter? E. Is not distribute. It does end with an E though. Yes? A. Why are we always using vowels first? Do, 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 do. Huh? N. Definitely not distribute now.
To eliminate.
It's not, well, we are. We need to use this to help us eliminate that radical in the denominator. If it was eliminate, then the N is in the wrong place. Yeah, something that will help us get rid of oi. You've done it in the past. We used this word in the past. And we tried to play hangman in the past. And every time I play hangman, it is the same word. I've only played hangman with this word. An I. Selfish. Boop. There is a C. I think you guys are going to know what this is now. Or maybe not.
Cancel.
No. Much too long of a word for cancel. Unless I'm doing it in a different language, I guess. D. Boop.
Any L?
Is there any L? Boop.
Is there an O?
There is an O. Now maybe you guys will know what that is. Yes, a conjugate. So, what's a conjugate? What's a conjugate? No. What's a conjugate? What's a conjugate? When the two binomials we're multiplying are the same, comma, oh, so conjugates are when the terms are exactly the same, except one's addition and one is subtraction. That's a conjugate. Because notice this. Watch. If I was to FOIL this out or double distribute, I'm going to get 9 plus 3 square root 11 minus 3 square root 11 minus 11. Look at what just happened with my oi. They just canceled out. Everybody see that? Therefore, I have no more radicals. If I do this to the bottom, I have to do it to the top. So the top, if we distribute, I get 18 plus 6 square root of 11. Is that right? The bottom, I'm going to show the double distribute. Questions so far? Are we okay there? Is this my answer? Is this my answer? Okay. So before I say anything, I want to mention something to you. How often have you seen negatives in the denominator? Not often. The reason why is because you're not supposed to have negatives in the denominator. So I'm going to mention this. You can write this answer two ways. One is you can bring that negative in front. Okay? The other is you can bring the negative up top, but then you'll have to put the parentheses in, which means that's going to distribute through. Understood? So it really is negative 18 minus 6 square root 11 on top. Are we okay there? That's number one. Number two, notice that the 18, 6, and 2 are all outside the house. Is that true? Agreed? What goes into 18, 6, and 2? What goes in 18, 6, and 2? Doesn't 2 go into all three of those? Okay. $18 goes into 2 how many times? Goes into 6? No denominators left, right? I'm going to give you guys a little time here to look at this over and tell me if there's any questions. I got to use a little bit. Go. Any questions on how I did anything? Nothing. We're good. Just so you guys know, anytime you have a problem that talks about rationalize the denominator, the steps for both of these should be there. Right? So number 1, identifying. This is at 59 minutes. Identifying if the denominator is a monomial or binomial. Right? If it's a monomial, we're going to first break down the radical. Identify the index. Create a haves and needs table. Multiply top and bottom by the radical of what we need. Outside times outside, inside times inside. Reduce if necessary. If the denominator is a binomial, we must multiply the top and bottom by the conjugate. Which means that we might have to, distribute or double distribute right? The numerator and the denominator. Simplify is necessary, right? Does that make sense? Are we okay? So all the rationalized denominators should have it cover monomial and binomial. So no questions. All right. Let's talk about radical equations. So this is a radical equation. Question is, what should we do first? Ooh. So the comment in class is add 3. And yes, it is adding the 3. So I'm going to do a sidebar really quick. So if I had this, wouldn't you subtract the 2? And the reason why we're doing that is because we're trying to solve for x. Is that right? So what we're trying to do is isolate this so that we can do the opposite operation. From here, wouldn't we do this? Agreed? However, it would be different if we did something like this. We would still subtract the 2. But we're no longer, now notice that the opposite operation we're taking here is opposite of multiplying by 3, so we divide by 3. Over here, this is actually the operation. So we'll still do this so that the x squared is by itself. Then we do the opposite operation of that. Does everybody understand? Okay, so the opposite operation is going to be square root and so on and so forth. Make sense? So every single time we're solving for x, we're always trying to isolate so we can do the opposite operation. In this case, with radicals, it is this that we need to isolate. So number 1, we're isolating the radical. So step 1 is isolating the radical. What do we do now? Say it again. And why did you want to raise both sides by the second power? Because the index is 2. What if index was a 3? Then we'll raise it to the third power. So why don't we say how about that? So what she's saying is then what we have to do, because the index here is a 2, we're going to raise it to the second power. What did I say about square and square roots? When the index and the power are the same, they're opposite operations of each other, so they cancel out. So that's the reason on the left it's just a radicand coming out. Solve and check. So, remember how I said to you guys that I'm not trying to create more work. I'm trying to give you what you need. So the check isn't going to be for every problem. The check is going to be needed. Check is going to be needed what does it mean by the eventh roots? Meaning the index or the root is even. So how do we check a problem? The exponent. Where are you plugging the exponent into? Oh. Into? Which one? So whenever you check, it always has to be, the value that you found has to always be plugged into the original equation. The original equation. And you're not moving anything around. You're just dealing with the left side as a left side, the right side as a right side. Since the right side is already a number, we're going to leave that alone. We're not moving the 2 anywhere. We're not moving the 3 anywhere. We're just going to stay put here. And if that checks out, then I can box my answer. Questions? So you might want to write some notes down. Like checking has to be from the original equation, the given equation. If it checks, then we want to box the answer. If not, we'll have to reject the answer. Questions? Excellent. Why is it only for even? The reason why it's only for even is because we can't take a square root or eventh root of a negative number. But for odd, we can have the cube root of a negative number. So like cube root of negative 27 is okay. But the square root of negative 25 is not a real number, right? So we have to reject those because those are not real, okay? So that's why the eventh root is necessary. The odd root is not really necessary. Any questions? Any other questions? Great question, by the way. Okay. Let's let you do this one then. Since we're so smart. There you go. Good luck. What? Mm-hmm. Mm-mm. You can't, because it's binomial. So if you're only given one answer and you threw it out, do you have an answer? You only have one pair of AirPods and you threw it out. Do you have any AirPods?
Maybe I got something wrong with the negatives.
Or maybe you didn't.
Or maybe it's the wrong answer. Yeah. You said that like negatives wouldn't be valid, right?
Huh?
Like negative, or is that only negative indexes? No one pays.
Well, there's no such thing as negative index.
Oh, okay. So, I think I missed something.
But if you're given an answer and and you threw that answer out,
Then okay. Then there's no answer.
then there's no answer. Did everybody else get no solution as well? Or did you get a solution of 7? Did everybody get 7? If you got 7, that means you didn't check. If you checked, then you would know that you have to reject that. But here's the cool part. Right here, I already know that there is going to be no solution. Why? Why would I know from that statement I have no solution? Why, from this statement, do I know there's no solution? Why is it? Okay, what does that mean? Why do you assume that everything on the left side is positive? I mean, that is a great statement, by the way. Okay, so you guys know this symbol as a square root, is that right? If I was to assume that the number in the radicand, or inside the house, was negative, is that possible? If the number inside the house was negative, is it possible to take the square root of it? No. That'd be imaginary, right? Or not real. You said everything on the left is positive. You're right. That's why I said it's a great statement. It's not positive because that the radicand is positive. It's positive because there's no sign in front of that radical. When there's no sign in front of that radical, it means that that radical is a positive number. Can I take a square root of any number and get a negative number? No. This is the reason why the square root of whatever can never be negative 9. However, if there was a negative in front of the radical, then yes, I can get negative 9. Because then just the square root would just have to be 9. Okay? So the reason why I didn't point this out is because for most of you guys, during an exam, the anxiety is so high that you're just going through those steps. Isolate the radical, right? Raise both sides by that index, blah, 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 right? So from here, you guys would have just gone, okay, index is a 2. The problem is that when you check, then I have that. Does that make sense? Questions? Does that help you with 8, 9, 10? And just so you guys understand, what if this was an x? I would still add x to both sides. But then the right side is going to be x plus 2. Right? And if it's x plus 2 and I square both sides, that means I'm going to have an x plus 2 squared. Which means that I got to write that out twice and double distribute. So that means I'm going to see a square term and an equal sign. So that means I'm going to see quadratics. Woohoo! Holy moly, factoring came back again. No way. Huh, interesting. So in other words, you're just telling me that what Chan said from the get-go is true. Factoring keeps on coming back and haunting us. Huh. You mean Chan wasn't lying to us? Just throwing fear in us? That we need to know how to factor? Oh, dang it. Chan was telling the truth. Son of a gun. Son of a gun. So, any questions? Nothing? So, just like last week, we got ahead. And just like this week, we also got ahead because we got ahead from the get-go. Meaning that this week's notes are done. So you should be able to do everything on the Lab Work 13. But I already told you guys you could have started Lab Work 13 already. You can do some of the problems already. But now you can do all of the problems. So what's going to happen on Wednesday is that we're going to move into next week's notes. We're going to get into those imaginary numbers. So we're going to take the full class for those imaginary numbers, and let's see if we have any questions and we're able to ask those questions. Good doke? Any other questions from me at this point in time? I would tell you to try to get the lab work done. And then you have one more assignment this week, which is when I send you guys the answer key with the rubric, I want you guys to self-assess, look yourself in the mirror, and give me an honest opinion on what you think your grade should be. Okay? So ladies and gentlemen, please have a wonderful, blessed day. Please be safe. Love you guys. See you guys on Wednesday. Later.